Okay, so we've got another variable acceleration example. So a particle of mass 6 kilograms is moving on the positive x-axis at time t seconds. Displacement s is s equals 2t to the power of 3 over 2 plus e to the minus 2t over 3 meters. We're going to find the velocity when t is 1.5 and find the force acting on the particle when t is 2. So the idea is that velocity we find by differentiating the displacement. So we want to get ds by dt, and that's going to be 3 over 2 times 2, so 3t to the power of a half. Differentiate e to the minus 2t, you can get minus 2 times by e to the minus 2t, so we can get minus 2 e to the minus 2t over 3. And we want to find a velocity when t is 1.5, so all we need to do is substitute 1.5 into that, and then that will give us the answer. Okay, and then putting down a calculator comes out as 3.64 meters per second. Part B is asking about force. Well, the idea is that force is the mass times the acceleration. So we're going to use that. And the acceleration is equal to dv by dt. We need to differentiate the function we found in part A and then substitute t equals 2 into that to get acceleration, and then times by mass to get the force. So dv by dt, we're going to do half times 3, so 3 over 2, t to the minus a half, then times by another minus 2 to get plus 4, e to the minus 2t over 3. We want that when t equals 2, so we want to substitute t equals 2 into there. So when t is 2, the acceleration is 3 over 2 times 2 to the minus a half, plus 4 e to the minus 2 times 2 over 3. And again, we'll just use a calculator to work out what that is. I get 1.09, it's 3 significant figures for the acceleration. Then the force, just using F equals ma, it's just going to be 6 times by that number that we've just calculated, which comes to 6.51 newtons.